graph. Today, let's learn about data representation. Data representation is the method of representing information in terms of pictures, symbols, graphs, or numbers. The information that we collect is called data. We can reach certain conclusions on studying the data. There are different methods of data representation. One of them is bar graph. Bar graphs may be horizontal or vertical.
Now, let's look at the data chart of the flowers collected. We have already represented this data using a pictograph. Now, another way of representing this data is through a bar graph. Every bar graph has 1. A title, which tells us what the bar graph is about. 2. Both the side and the bottom of the graph have a label which tell us what kind of data is shown. 3. The scale tells us the number each block is equal to. Now, let's see how we can read this bar graph of the flower farm example. The title, Flowers Collected, tells us the bar graph is about the number of flowers collected. The labels give us the information that the data is about who collected the flowers and how many. The scale tells us how many flowers were collected. Hence, from the bar graph, we can say Simi collected 5 flowers, Sanya collected 7 flowers, and Suzanne collected 4 flowers. Max, the mouse, ate some fruits. Let's read this bar graph. Here the title, Fruits Eaten by Max, tells us the bar graph is about the number of fruits eaten by Max, the mouse. The labels tell us that the data is about the kind and number of fruits eaten. The scale tells us the number of fruits eaten. Hence, from the bar graph we can say Max ate 2 mangoes, 4 cherries, 5 apples, and 3 oranges. From the information so obtained, we can say how many fruits Max ate in all, how many more apples he ate than mangoes, and so on. Hence, we can obtain a lot of information from a bar graph too.
Hope it was fun to learn about bar graph.
Let's see a practical example where the bar graph can be used to understand data more easily. This is a graph of average temperature of various cities. In this graph, we mark 10 degrees in equal intervals. And we have been given data for 6 cities: A, B, C, D, E, and F. Now, just by looking at this graph, let's try to answer a few questions. Here's the first one. Which is the hottest city among these 6 cities? Well, it's obvious. It's city F, as its average temperature is highest among peers. Next one. If temperature greater than 25 degrees Celsius is warm, list the warm cities. This is the 25 degrees Celsius line. All cities having their average temperature above this line will be included in the list. So the warm cities are B, C, and F. Here's the last one. What is the difference in temperatures between the hottest and the coldest cities? The temperature of the hottest city is approximately 48 degrees Celsius. And the temperature of the coldest city is around 9 degrees Celsius. So the answer is 48 minus 9, which will equal 39 degrees Celsius. Apart from helping us answer such questions, the most important way in which the bar graph helps us is that just by looking at it, we get an idea about each of the categories. In this table, we have two rows. In one, we will have the class interval, which will be the price range of pens, and in the second, we will have the frequency, that is the number of pens sold of each range. So these are the different class intervals that are given. The first range is pens that cost between 10 and 20 rupees. We can see that the upper limit of one interval is equal to the lower limit of the next interval, making it continuous. As it's continuous, the first group would mean 10 rupees is less than or equal to the price of the pen, which will be less than 20 rupees. The lower limit is included, but the upper limit is not. So in the second group, 20 is included along with all numbers less than 30 but not equal to 30. In the second row, we have the number of pens sold for each category. 15 pens of this category were sold, 20 of this category, and so on. Until now, we have seen examples of bar graphs but never seen bar graphs used to represent continuous form of grouping. Let's see how we can do that. The first thing that we do is draw the x and the y axis. We draw the axis and make equal intervals on each of them. Then we label the axis. Since we want to represent the quantity of each class interval, we have the pens sold in the y-axis and the price range of pens on the x-axis. The steps are similar to the ones we used to draw a bar graph. Now we have to choose a suitable scale for the y-axis. The number of pens sold range between 5 and 30. A scale of 1 centimeter equals to 5 pens on the y-axis would be perfect, as we would need just 6 divisions. We start writing the values on the y-axis. 5, 10, 15 and so on up to 30. And on the x-axis, we start writing the price range of pens. The first range is 10 to 20, then 20 to 30, and so on up to 50 to 60. That's it. Now we just have to draw appropriate bars for each class interval. For the range 10 to 20, the frequency is 15. So based on the scale, we draw a bar of length 3 centimeters. For a frequency of 20, we draw a bar of length 4 centimeters. And we continue the process till we reach the last range. This is called the histogram. Bars used to represent continuous class intervals. Remember, for bar graphs, we did not have intervals here. We just had plain simple categories. But here, we have intervals on one axis and quantity on the other. What we did here was simple. We choose a scale and draw bars for each continuous interval. But note that the intervals were continuous. 20, which is the upper limit of the first interval, is used as the lower limit for the next interval. But what if the intervals are discontinuous? We will understand that in another video. In this table, we have the price range in one row and the frequency in another. 15 pens that cost between 10 and 20 rupees were sold. 20 pens that cost between 20 and 30 rupees were sold, and so on. Frequency is simply the number of times something has occurred, or you can say how frequently something has occurred. And these intervals, as we can see, are continuous. The upper limit of one is the same as the lower limit of its next interval. We saw how we can draw a histogram for continuous class intervals. We have the x and the y-axis. We have the class intervals on the x-axis and the frequency on the y-axis. For the interval 10 to 20, we draw a bar to represent 15 pens. For 20 to 30, we draw a bar to represent 20 pence. Observe that here there are no gaps between the bars like we had in the bar graph. In the same way, we draw bars for the remaining 3 intervals. We use histograms to represent class intervals. By drawing a histogram, we have the class intervals on the x-axis, while for a bar graph, we have categories. But here's something really interesting. Sometimes we may not need to draw the entire histogram.